All right, so in problem 3, I've copied the diagram. The top up above had given you all the information, but it's all labeled here in the diagram. So 3A1 asks us to find the angle ACB. So I'm looking for this angle here. So I'm going to call that my X. So I want this angle here. I know 3 sides, so that's cosine rule. So if I look at my formula booklet, cosine rule says that when I want an angle, I'm going to use this one. And remember, I've got this angle here matching with this side across from it. So that's the only part that I need to make sure of. These are just my other 2 sides, the B and C. So A matches the side across from it. So cosine of our X value, we don't know what the X is, equals, so I'm subtracting the side across from it, so these are my other 2 sides. 12 squared plus 10 squared minus 15 squared over 2 times 12 times 10. So these 2 sides match up. So let's clear this out. I'm going to have 12 squared plus 10 squared minus 15 squared divide by 2 times 10 times 12. All right, so remember this is my cosine value. So cos X is 0.07, whatever all that was. So X, I'm going to do the cos inverse of that. And I get about 85.5 degrees. All right, so my ACB, so we could say measure of angle ACB is about 85.5 degrees. Now, problem 2 asks us to show that size DCE is 85.5, correct to 1 decimal place. So DCE, well, I can see that these are vertical angles, so I know they're equal to each other. So angle ACB is equal to angle DCE, therefore angle DCE must be 85.5 to 1 decimal. All right, Surveyor measures the size of angle CDE to be 2 times DEC, so CDE is twice DEC. So this one is twice as big as this one. So if I call this one Y, I'm not going to use X because I've already used X up here. So this one is twice that, 2Y. And of course I know all 3 of my angles are going to add up to make 180. So it says use 85.5. So I'm not going to use this big number in my calculator. It's telling me to use 85.5. So find DEC. So DEC is my Y value. Oops. So part B1, we've got that angle X plus Y plus 2Y. All of that must add up to 180. We know for X we're going to use 85.5. Y plus 2Y is 3Y. Okay, so, whoops, that's not what I wanted to do. I'm going to subtract my 85.5 and then I'll divide by 3. And I get 31.5. So Y is 31.5 degrees, and my Y was the same as angle DEC. DEC was my Y value. So I know that the measure of angle DEC is 31.5 degrees. And again, that's to 1 decimal place using this one. Find the length of DE. So now I'm going to use another letter. So I'm going to use Z for this now. So DE is down here. I know the angle across from it. I know this angle and the side across from it. So I can use sine rule. So I want to find the side DE, so side over sine of the angle across from it was 85.5 equals side length over sine of the angle across from it. I'm going to multiply this to the other side to get my z value. And I'm sure this one we're going to have to round. So 9 divided by sine 31.5 times sine 85.5. And we get about 17.2. It makes sense that this is a lot bigger than the 9 because it's across from 85 degrees, whereas the 9 is across from 31 degrees. So about 17.2, we're measuring in meters here, I believe. Let's see. Oh, nope, measuring in kilometers. Let's fix that. All right, so now last, find the area of DEC. Well, now I know side, side, I can figure out this angle in between. So I can say that, whoops, 3C, not 4. Half of side, side, oops, 17.1 dot dot dot, because I'm going to use my not rounded value, sine of 2, so 2 times y, 2 times 31.5. All right, let's put that into our calculator, and I can just put it all in at once. So a half times 9 times this side times sine of 2 times 31.5, and I get 68.9 square kilometers.